Hi, in today's video we will try to create a plasma effect on Commodore 64 using a basic programming language. Now the plasma effect is very colorful illusion of moving liquid on the screen, which is really hard to do in basic programming language on Commodore 64, but we will try to do something close enough. Now to achieve this effect we will use trigonometry functions like sine and cosine functions on Commodore 64. And because we are in BASIC, we'll try to do all of that in single line of code. So yeah, let's begin. Okay, for the start we will need x and y coordinates because we are going to use trigonometry functions. So for our y-axis, we will have just infinite increment of y variable, simple as that. So this applies that we are going to generate images or plasma effect on the screen and just keep on scrolling downwards. So our y coordinate or y variable is just going to be incremented infinitely. So for our x coordinate or x variable, x will be from 1 to 40 because we have 40 columns on screen of Commodore 64. So let me leave this number 3 for now empty, and number 4. Number 5 is just we're going to close for loop, and on line number 6 we will just jump to line number 1 back. So yeah, infinite running. So okay, so let's create our algorithm. For our algorithm we will going to use trigonometry functions. So let's start with simple sine function, and we're going to divide our y coordinate with let's say 4, and then we are going to multiply everything with cosine of x divided by 4. Then we are going to add a little bit more, and for this purpose I will use just logarithm of x plus y. So this part will give us a constant change as the y coordinate is increasing. The logarithmic function will give us slightly different numbers, and this will create variation in our image. So how should we print this on the screen? Well, plasma effect is all about colors, and what we are going to do is simply poke into memory address 646, which is memory address where Commodore 64 stores text color. So yeah, we're going to poke this directly into the memory result from our algorithm or variable a, and we're going to multiply it with 2. That's it for now. And because the result from trigonometry functions can be negative as well, we will create absolute value of this. Okay, now that we set the color of text color, we are going to simply print some character on the screen, and I'm going to use is this little circle, and we need semicolon as well, and that's about it. So let's run it and see what should we get now. And here we go. It's a little bit slow, and those empty spaces are not empty, it's just blue color, the same as the background. So yeah, it's a little bit slow. The reason for this is, of course, our trigonometry functions. So as you can see, we do have some twisted circles and stuff. but we are going to change this a little bit more because this is not, no, it's not really the plasma effect. Well, it kind of is, but, and this will go forever and ever, of course. Well, at least until we reach the maximum value for the y coordinate. Yeah. Let's speed this up a little bit. Okay, our algorithm can be changed. Of course, this is not the only one. You can use whatever you prefer. Well, so let's try to use 2 sines. Yeah, let's see now. Okay. Oh, yellow is fine. Okay, so what can we change here just to make it more interesting? Well, you see this number 2 here on line 4. Well, changing this number will change the number of colors that you're going to use on the image itself. So if we increase this number, we should have a bit more color on our plasma effect, and you will see this right about now. I'm already seeing this. You see? So this is the same image as before, just using more colors, and we have, well, better say, we see more layers in between each individual object on the screen. The other is this divider here, this number 4. So I will change this into variable. I will add it here just so let's call it. So with this number, we can zoom in or zoom out depending on the value. So if the value is bigger, this will give us a zoom in effect. If the value is smaller, this will give us a zoom out effect. So let's change this force with variable m. Yeah, I store everything. Just let me check. Yep. So let's generate the image one more time. And this is exactly the same image, just zoomed in a little bit more, right? Now let's see how that looks like. Yeah, that's the whole concept of generating these images like this. So it's not really that we are creating animation, but we are constantly generating the image and we are scrolling down. The downside, it's very, very slow, simply because of use of these trigonometry functions. Okay, let's try to play a little bit more. Of course, we can add additional changes to this algorithm. So let's multiply the sine with the y variable, multiply with 3, and let's multiply with 2 our cosine of x coordinate. Yeah, and of course I will just change a little bit number of colors. Let's make it smaller. So let's run this one. Let's zoom in, zoom out. Zoom out. Okay, like this. And let's add something else. So let's multiply. Yeah, about this. It is slow. Okay, so let's work with this one. So yeah, let's change. Okay, so let's down. Let's decrease the number of colors because that's too much, I think. So let's see now. Again, the same image, except we're using way less colors. And of course, the transition between layers is going to be less subtle. So let's see how this looks like. So what we are going to do now is try to shrink this code in a single line code. So we're going to write a one-liner in BASIC, and this will give us some benefits, and I will explain why is that shortly. So first of all, we will get rid of this m variable. Well, let's try to write this from the beginning. So first of all, I want to get rid of this for loop for the x variable, and we will change this because the one-liner is going to have just single line, and we are going to constantly loop through it. So at the end of our line, we will just have go to 0, right? So whatever is in between will be constantly executed. So we will get rid of this for loop. Now to get rid of this for loop, we will use a little bit of algorithm that is going to increment our x variable by 1 if the x is smaller than 40. So we're going to increment from 1 to 40, and then again from the beginning from 1 to 40, and so on and so on. So to do this, we will have x equal 1 minus, and then we will just have condition if the x is smaller than 40, then multiply everything by x. What this should give us, in case that x is smaller than 40, we should have this x plus 1, or better say 1 plus x, sorry. In case that x equals 40 or it's bigger than 40, then what we should have is 1 plus 0 actually equals 1. So this little piece of code will replace our for loop. Now for the y variable get increment by 1 after this for loop is done. So for each y variable increment, the x increments 40 times, right? Goes from 1 to 40. So what can we do is simply increment our y variable with 1 divided by 40, and 1 divided by 40 is equal 0.02. 5. This will increment the y variable by 1 every 40 cycles, so every 40 iteration of our code. Of course, y variable is going to change every iteration. It's going to be incremented by 0.025, but this will actually be like benefit in this case, because the plasma effect will be more obvious. It will be slightly changed, a little bit different. Okay, let's start with our y variable increment, and I don't need to write this leading zero, so I will just say 0.025, and for the x is equal 1 minus x less than 40 multiplied by x. So this is our x variable. Okay, now let's start to write our algorithm. So a is equal, and what we are going to do is we're going to use abbreviated codes just to make everything fit into single line of code. So sinus of y divided, and I'm going to dump this m variable. I'm going to just use numbers and minus, and let's go with sine again, x divided by 5, and oops, how this happened. And then we are going to add logarithm of x multiplied by y, and then we are going to poke at memory address 646 our absolute value of a multiplied by, let's say, 2, and then we are going to simply print, oops, and then we will just go to line 0, so jumping back to the line 0. So go to 0 is, we can just say go to, and abbreviated version is this. So this is go to 0. So here we go. This is our code. It's single line of code. So let's list it and take a look at it. Oh, I need to get rid of this. Oh, so what I'm going to do is set new, and then I'm going to crunch this line 0 one more time, and then let's list it, and here we go. So this is our code. I hope this will work. So let's run it. And you can see it's now slightly distorted, like the image is not perfect circles, it's not really, and this is the result from this logarithm function, but also from this, the way how we increment the y variable. So the y variable changes in smaller increments, and this gives us a little bit distortion to the image, which is nice to have in this case. But again, slow. Okay, so what else can we do here? Well, let me abbreviate this code one more time. Yeah, we can get rid of this as well. Okay, so what we're going to do now is we're going to make this divider number 5 more variable. So let's change it during our cycles. So we will get rid of this number 5 and replace it with variable m. And now variable m, let's define variable m. So variable m can be something like logarithmic multiplied by y one more space. So I get rid of this addition in our algorithm, and I use the same part as the variable m that I'm going to use to divide y coordinate and x coordinate with. So yeah, let's try to do this. Okay, let's run it and see what should we get now. This should be like weird. Yeah, let's see. Okie dokie. So what else can we do? Okay, let's change the plus sign here. Let's abbreviate this one more time. Okay, so what else can we do here? Well, we can add here square of y, just to make things a bit more interesting. And I changed this multiplier with plus sign, so let's see that how this will up. I missed something, and I can see it right here, and I do need one more thing to like this, and this will be, wow, full 80 characters. So let's list this code and run it. Oh, I do have error. What have I done? Poke. Yeah, that's good. Print. Yeah. Oh, wow. Jesus. Okay, let's abbreviate one more time. And of course, I misplaced the semicolon and column. Okay, now it should work. Let's list our code and let's run it. Okay, let's see. What should we get now? Oh, I like this one. I already like this one. Okay, enough of that. Let's subtract m variable, and let's square it. So let's, oh my god, what am I doing? Let's square it, and I need to abbreviate one more time. So this should be a little bit different. Let's run this one. Oh, that. Yeah, this one was really nice. We can do one more thing. To shrink this even further. So let's abbreviate one more time. Because we are creating this plasma effect, which is all distorted and everything, we don't need to use exactly 0.025. Well, you can cheat a little bit and say one extra character. It will still work. Okay, let's run it one more time. Now I'm definitely going to speed this up even faster. Now, yeah, this is all that I have for you today. Of course, we could play with this to infinity, just changing this algorithm a little bit here and there, just to get a little bit different effects on the screen. But yeah, in general, this is it. So yeah, until next time, goodbye.